Okay, I'm Mark Reed. I'm with GMO-free Lancaster County, and we're doing an interview with Ray Seigler today. He's a soil microbiologist, and we're at the SoilNotOil conference here in Richmond, California. So Ray, you're a soil microbiologist. Can you talk about your career? You were with the EPA?
Okay, I'd probably describe myself more as an environmental microbiologist, but my career after finishing various university trainings brought me first to Oregon State University as a professor of microbiology, and I worked in the department there for about 16 years, and in 1984 had an opportunity to go to work for the United States Environmental Protection Agency. I wrote a research plan describing my concept for how the federal government should go about determining the biosafety concerns, issues, hazards associated with the release of genetically engineered organisms, both microbes and plants, into the natural environment. So I became a senior research scientist in charge of a team that varied over the years, 6, 8, 10, 20 people. And we conducted our own research within the EPA, and we also funded research laboratories in academia throughout the United States.
So, proponents of GMO technology say that genetic engineering techniques, they've been going on for thousands of years, and it's no different than traditional crossbreeding. Is that really true?
There's so many times, so many ways I've heard that proclaimed. Let me just start out, because it's a big question, it's an important question, and there are many kinds of answers. But let me start out by making this statement. If it was so normal, so natural, it's occurred for thousands of years, the United States Patent Office would not consider it to be as original a technology as they do. The United States Patent Office offers patents on each and every molecular construct that industry would produce. So right off the bat, it raises the question and the issue, how can this be a natural, ongoing, thousands of year process if suddenly you can get a patent on it? Secondly, from a biological perspective, what is genetic engineering? Genetic engineering, as it applies to the current applications to genetically engineered crops, is bringing in 1, 2, maybe 3 genes from 1 or 2, 3 or 3 very different, completely unrelated organisms, such as plant virus, soil bacteria, etc. And through a forceful, literally ballistic shooting explosive process, the new combinations of genes are shot into, inserted into randomly, chromosomal fragments of a plant. Does that sound natural to you? Then in natural crossbreeding, it's a process that brings together a male cell and a female cell in plants, as in animals, and the entire contents of the genetic material of the one cell combines with the other. We're talking 20,000, 30,000 genes, perhaps on 20 different chromosomes. Now that is the natural process that could only have evolved over the millennia on the planet. It is a sexual process. It occurs out of doors, indoors, in between, wherever the time is right, but typically we see it in an outdoor setting. And coming back to genetic engineering, it's a combining of nucleic acid components from these highly unrelated organisms, as I said, in an asexual manner, producing a new combination of genetic material that has probably never before existed on the planet. To me, it just doesn't make sense that you could claim that these are the same process.
Well, you talked about patents. So when they say it's the same when they're doing public relations, but when they go to the FDA or the patent office, they say then that it's a totally unique and different patentable technology. How do they get away with that?
Well, corporate PR is what it is. Lawyers don't ordinarily line up and claim on a legal setting as to whether the true words have been spoken. So corporations, much in political campaigns, individuals say things that twist the truth, bend the truth, are not the truth, and all the combinations above. And typically, on a political scene, when running for an office, if you exaggerate, those people usually don't wind up in a court of law. And the same thing holds true for corporate statements. It's PR, public relations.
Now, there's also a lot of talk about bees. Can you talk about how these genetic crops and their associated herbicides and pesticides are affecting bees?
Mark, that's a very big question. So I'll give this a try. As you know, genetically engineered crops are really designed for one purpose only, and that is to survive the direct application of pesticides, usually herbicides. And they are designed for that purpose, they are sold for that purpose, and they are managed for that purpose. But year after year after year use of both herbicides as well as those genetically engineered crops that are genetically engineered to produce internal toxins to kill insects. When all of that comes together and it's used year after year after year after year, eventually the target pests will become resistant. So your question about the honeybees and the damage to them that has been raised by many scientists around the world primarily is an insecticidal use issue. But in the end, I'll come back to the herbicide because there's been a recent study that even counters that generalization. So when you have insect resistance, you got to add more poisons, more toxins. So somewhere in the range of 2003, 2004, seed purveyors in the biotechnology industry developed patented procedures to coat their seeds with a variety of additional chemicals. In this case, insecticides that kill insects and fungicides that kill fungi in the soil. And in 2003, 2004, those new class of chemicals that became widely available for farmers are called neos, or neonicotinoids. Many of us were not aware of the extent by which those chemicals, those insecticides, those neos were being used. And as I mentioned in my presentation earlier today, not only were we not aware that they were used, But now we know that they are the order of 10,000 times more potent to beneficial insects like honeybees than DDT. 10,000 times. Not double, not triple, not 10, but 10,000 times more potent. So I don't think anyone on this planet really should be surprised when you have, by plan, a new class of insecticides that is called a systemic insecticide, meaning it just spreads throughout the entire plant, from the roots to the nectar to the flowers. Nectar and flowers where the honeybees visit with these highly potent neonicotinoids, that there could be some type of deleterious effect. Well, it's very naive of all of us to think that honeybees are only visiting a plant at the point of nectar. Honeybees do drink water, and it is now known that these systemic pesticides form a part of the morning dew droplets on the leaves. I don't know if you've ever been out on a farm at sunrise, and if there is moisture in the ground, it's not uncommon for a droplet of water to be hanging off the end of a leaf. Well, it turns out that in that water there's a highly concentrated amount of the neonicotinoids. So there is a second place that our honeybees can visit and become exposed to these toxins. Other scientists have shown this to be the case, and other scientists have also shown and measured the exact amounts in parts per billion at which these neonicotinoids can kill honeybees. And it's right within the range, it being the parts per billion range, for a lethal dose on an adult bee. It's very close to the same concentrations of those neos that can be found in the nectar. Coming back to the droplet of water at the tip of the leaf, no doubt about it. Concentrations of the neonicotinoids in those water droplets are well beyond the toxicity necessary to kill a honeybee. We have also learned within the last 3 years a little bit about the biochemistry and addictive nature of neonicotinoids. Neonicotinoid simply means the new nicotine. We all know from tobacco, cigarettes, that the addictive power lies within the nicotine. Chemists have slightly altered the structure of nicotine to produce the neonicotinoids. And it's amazing, but with hindsight, wow, is this surprising? I don't think so. That the honeybees actually may become addictive to low concentrations, sublethal concentrations of neonicotinoids in sugar water in experimental tests. So you put out sugar water in this dish, sugar water in this dish, and you add a very, very low part per billion concentration of neonicotinoids in that dish. And after a while, the bees are just visiting the neonicotinoid sugar, not the regular sugar, because they become addictive. There is the equivalent of what we would call a high. And the sad part of the manifestation of that, coming back again to research that's been done by European scientists, they're able to put a microchip, if you will. A microchip can be glued to the abdomen of a honeybee to use it as a tracer device to follow where that honeybee, one specific bee, spends its time in its day. And when you expose a honeybee to neonicotinoids, it looks like a drunk walking down the road. It's a high for the honeybee. And at sublethal doses, often those honeybees don't make it back to the hive. They don't make it back to the hive, and they succumb to the so-called sublethal concentrations of neonicotinoids. So collectively, that's kind of the background story for the honeybee and the new generation of insecticides, potent insecticides. Because I'm an environmental scientist, I can't help myself, but I want to take it one step further. American scientists within the U.S. Geological Survey have recently, within the last couple of years perhaps, shown that unlike what industry promised, the neonicotinoids that are on the seeds associated with genetically engineered crops, those neonicotinoids travel off the farm. Those chemicals do not stay locked onto the seed as industry promised. So in an irrigation event, a rainfall event, shortly after those seeds are put into the ground, we have massive migration of these chemicals across the soil, coming off the farm, going to new habitats where no one cares about controlling pests, sometimes enter riparian habitat zones, the closest creek, and then expose an entirely new group of life forms that have nothing to do with what's in the soil. And you know it goes on. It's just like the DDT story. The new contaminated, say, aquatic insects will be eaten by the birds. Then the birds get a hyperdose of neonicotinoids, and according to some scientists in Holland, they believe that the songbirds are particularly vulnerable to death from consuming a lot of insects that carry the neonicotinoids in their body. And what I just told you is very similar to the scenario that was being developed by Rachel Carson when she wrote her book, what is it now, 60 some odd years ago. We have learned nothing apparently in the 60 some odd years, or what we have learned has come too slow, too late. Neonicotinoids have been temporarily banned in Europe, not in the United States. The regulators within the US EPA looked at the same information, the same data as the regulators did in Europe, and they came to diametrically opposed decisions. Go figure. I think the difference is in the concept of the so-called precautionary principle. It's not a political principle. It's a principle developed by scientists at an international meeting. And basically the bottom line is, when you're in doubt, figure it out first before you go about large-scale exposures. And again, warnings echo in my brain from Rachel Carson, who said she said more or less the same words.
So we are already at the point where we have widespread industrial chemical farming. That's you're only talking about bees, but that's going to affect soil and overall biodiversity. What happens when there's completely contaminated?
You're absolutely right on that. The stories that I've been just sharing are those that are used by industrial agriculture in so-called industrialized nations like ours. One must raise the issue, well, what impact might all of these chemicals have, say, on farmers who practice organic agriculture, sustainable agriculture, who practice the principles of agroecology, soil health maintenance, and so on. And how would that affect them? Coming back to the water transport of neonicotinoids is a good example. Irrigation water, rainfall runoff comes from Joe's farm on one side of the road that may be practicing industrial agriculture as a GMO base and contaminate the surface soil of a organic farmer close by, or certainly contaminate creeks and streams, carry those neonicotinoids more miles down the road to other farms who use that water for their irrigation purposes. And we're just learning now that all of these chemicals, the barrage of pesticides that are placed upon genetically engineered crops, affect what's beneath our feet. We don't see it, we can't count it unless you're a specialist. We can detect it now if you look for it. Impact the life and the life forms of what's going on in the soil. And you say, what the heck difference does that make, Ray? We can't see it. They're out of sight. Who's going to know? Who cares? Well, who will care are all of the farmers on the planet, and there are millions, who practice regenerative agriculture. The very essence of their social economic status as a farmer depends on a healthy soil. If that soil is inundated by even a small barrage of the many pesticides, the soil is no longer healthy. His being the organic farmer, his crops the crop yields will suffer. The planet will suffer because the normal processes are no longer in place to capture or sequester carbon dioxide from the atmosphere and leave it into the soil. And other metabolic processes will change. This is a very serious problem. It's not as simple as the USDA would like, with this farmer getting along with this other farmer. It's not just a matter of a handshake and an agreement. It's all about maintaining the healthy status of the soil, food, web components of life that are present beneath our feet, whether it's in our backyard or whether it's out on a commercial agricultural field. They're there, they're important, it's evolved over the millennia on the planet, and it's very sensitive to the chemicals that are being used today.
So we talked about bees, soil, and biodiversity. How about humans? I'm from GMO-free Lancaster County, and we've begun testing mothers' breast milk for presence of glyphosate, and we're not scientists. What do you think of efforts of people testing their water and their food, and in lack of testing by, say, the FDA?
Yeah. Okay, I can help you pretty strongly in some areas, and in a couple of areas I'll waffle. Let me offer the waffle first. I'm an environmental scientist. I used to train students who wanted to become doctors, but I trained them in microbiology and not in human health. So the specific impacts of industrialized agriculture on human health is somewhere between oh my God, all of these people are contracting cancer, and oh my God, there's no effect whatsoever that we can measure. The same kind of scenario that existed with the evolution of knowledge with DDT, PCBs, furniture that is purposefully contaminated with fire retardants, plasticizers in chemicals, other plasticizers and potential carcinogens in our toothpaste, women's makeup, and on and on and on goes the list. What is the significance of this barrage? Because there are toxic chemicals everywhere. It will require a thorough, concerted, long-term series of experiments using our best epidemiologists, and followed by and preceded by interviews, family interviews, etc. And it's a long-term process. The processes that we used in the past to figure out the health significances of all those chemicals that I just mentioned, it's not yet been done with glyphosate or other pesticides, most of the other pesticides that we're talking about. But let me go one step further, and this is where I will not waffle. Earlier this year, an international panel associated with the World Health Organization, whose sole purpose is to, one by one, to go through the scientific literature to evaluate the potential carcinogenicity or cancer-causing likelihood of a chemical. It's a voluntary organization. All of these people are professionals from various jobs around the world. Most of them are MDs, some are epidemiologists, some look at specifically the molecular biology of cancer-causing chemicals, etc. And over about a year's time, typically, they review the world literature. And in this case, 17 of these individuals came to the conclusion, as they have in the past with other chemicals, that glyphosate, which is the active ingredient in Roundup, is a probable human carcinogen, or a class 2A. There are 4 classes. 1 is the hottest, 4 is the weakest, and here we have class 2A, which is close as you can get to being called a frank carcinogen, just a notch down. And the only reason why they went the 2A class that they stated publicly was that they would like to see more human epidemiology studies before they collectively would feel comfortable in making a class 1 or not a class 1. So we're lacking that information that I referred to a couple of moments ago. But Mark, one of my biggest and recent professional disappointments is the apparent lackadaisical attitude that the press, some scientists, and certainly the American population in general has over this declaration. Hey, this is not a group of now boys and girls that work at this process on the weekend as a hobby. These are lifelong working professional scientists. Each of them has stature in their field. That's why they were chosen to sit on this panel. And the vote wasn't, say, 10-7. It was 17-0 to place glyphosate in this 2A category. For me, this is another warning sign. Maybe even not an orange flag, perhaps even a red flag. And by that I mean there are certain segments of the human population that will be more susceptible to exposure to potential or probable human carcinogens. And we know the very young whose immune system is not mature, the very old who have chronic illnesses, and those that may be on compounds, chemicals, drugs like chemotherapy, who have suppressed immune system, and exposures of the like of these kinds of chemicals is likely to cause an issue, a medical issue, especially in the young, who will have, by definition being young, the longest lifetime exposure to these chemicals. So, for me, it's not acceptable, because there are alternative chemicals, safer processes to use to control weeds, to be spraying these chemicals around public areas like schools, parks, even golf courses, and the like, community meeting areas, and so on. Glyphosate doesn't disappear within moments after it's sprayed. It sticks around, and depending on the conditions, it could be weeks to months, and could be many months. People that picnic, put their hands down where it's been sprayed, or maybe around the base of a tree, bring it into their mouth, they've inoculated themselves. And that's too specific, I understand. But public entities in particular need to be more sensitive to this kind of a declaration in order to protect the people they serve. For example, here we are in Richmond, California, and they have a city ban on the use of glyphosate. Delicious, beautiful, hurrah for them, big five for them for doing this. There are other nations of the world in which their cities, sometimes the county, sometimes an entire country, are talking about what are we going to do? How do we back off? If we want to declare a declaration to not use glyphosate, what will it mean? So they're going through their economic consequences and so on. Are we in the United States doing anything like that? I haven't heard. And I don't think we are, Mark. So, coming back to your last question, the presence of a probable human carcinogen in human body, human urine, human breast milk is entirely unacceptable. And I hope it's unacceptable to the local elected officials, from the mayors of the cities to our other elected officials, congresspeople, and so on, because they need to understand, to know the medical consequences of this international declaration. And so far, I see very little action. Mark, we do not yet know, as part of this, the absence of a long-term epidemiological study, the consequences of exposure to these chemicals, let alone what it means health-wise for us to carry glyphosate in our bodies. We don't know yet. And it's sort of like, you know, putting a mask on a person in a room and say the first one that finds the light switch wins the prize. How do you do that? Where do you start? What does it mean? Do you go that direction? Do you go this direction in terms of monitoring? And in terms of monitoring, I would, because it's time consuming, it costs money, it brings anxiety to the individuals who may test positive, that all of that kind of stuff be sorted out before you start. Because if you have 50% of the population that is contaminated, say breast milk is contaminated with glyphosate, what does it mean? What does it mean? What does it mean if this lady has 50 parts per billion and this lady over here has 5 parts per billion? They both, you know, are they looking at the same long-term hazards in their body? We don't know that. So that information is needed. It is crucial starting point, but that's what it is. It is a starting point, and it needs to come along with other useful backup supporting parameters. For example, the classical epidemiological interview. You know, the age, rank, serial number. How do you eat? What do you eat? Do you eat organic or not? Et cetera, et cetera, et cetera. What did you eat in the 24 hours before you were tested? And perhaps even some retests. Oh, okay, did you change your ways? Did you go from what you were eating, now you're strictly organic? Because we see a hypothetical, we see a significant drop. All of that is going to be deliciously useful information. It isn't going to give, the presence isn't going to give that baby who's nursing a sentence that says you're going to have non-Hodgkin's lymphoma before you're 40 years old. We don't know. We haven't a clue on that relationship. But if you do the surveys and you've documented the names of the people, and someday that individual has a problem, has a tumor problem, those records are there. And what a service you will be doing to humanity, to the world, to be able to make that kind of a connection, etc.
Wow, thanks a lot. It's just such a pleasure talking to you. Thank you so much.
Oh, thank you for doing what you're doing. What you're doing is what I can't do, and it is so important. I never want to be discouraging to those efforts in monitoring, and I hope you don't interpret it as any discouragement. It's just that let's bring people into the picture that you trust, that have some monitoring experience, epidemiology experience, and knows how to work chain of custody in your samples, how those samples are stored, blah, 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 blah. Not just for academic reasons, but very important repeatability of the science. And let's see how we can squeeze out some correlations, correlative information from the negatives as well as the positives. The low-level positives, the high-level positives. Very important stuff,
It
Mark.
takes all kinds of people to
Yes,
change, right?
exactly.
Okay.
Yeah.
Well, thank you.
Wonderful to chat with you, Mark.
Yep.
Thank you.